In this tutorial, we will go through the creation of a rules and material file. The goal of this video is to describe the topology of your fiber to the home design in such a way that it can be recreated by FiberPlanet. Before we head into the details of the FiberPlanet rules, let's align on some general fiber to the home terminology. A typical FiberPlanet design is created in a bottom-up way. This means that we start from the building locations, which we refer to as demand points. A building is connected to a drop box using a drop cable that goes onto the customer premises. These drop boxes are typically placed on the street side and serve 1 to 2 customers. We will refer to them as drop points. Everything between the demand point and the drop point will be considered as the drop layer. In the next phase, these drop points have to be locally connected to a cabinet in the street. These street cabinets will be called the distribution points. Anything from the distribution point to drop point is labeled as being part of the distribution layer. This includes the cable, ducts, and other equipment. Finally, these distribution points have to be connected to the point of presence or central office. This part of the network will be called the feeder layer. This concludes the default topology. FiberPlanet also supports designs with multiple distribution layers, or with an additional backbone layer. Back in Quantum GIS, we can open up the rules material by pressing the Edit Rules button. This takes us to the FiberPlanet graphical user interface. We can create a new set of rules by pressing the Create a New Rule Set button. For each set of rules, you can specify the currency. We could change it, for example, to US dollars. We can choose between a set of pre-configured rule templates. Each of these have their design parameters configured to achieve a specific network topology. For example, there is a specific set of rules that has been tuned for creating aerial networks. Another set of rules is made specifically for creating a network with 2 distribution layers. For this example, let's start from the standard rules. You could also change the name of your rules. This is useful if you want to swap between multiple configurations in a single workspace. Note that during a calculation, FiberPlanet will only read in those rules with the default name. Keep this in mind if you use multiple sets of rules. Press OK to create the rules. Notice that the same layers that we discussed at the start of this video return in this rules panel. There is a demand section, a drop section, a distribution section, and a feeder section. On top of that, we also have a common section, which includes some of the shared parameters. First, let's quickly go through the common section. In the General tab, we can choose if we are doing a fiber to the home or a fiber to the building design. We can indicate the technology. There's the option between PON and point-to-point or any hybrid of these. There is a section to configure the trenching parameters. This will be discussed in more detail in a separate tutorial. When you select a network with PON technology, you'll also get a section for splitter settings. This one has its own video as well. There's one final section where you can enter the costs of some general equipment types. Note that each of these costs can be changed by editing the value in the table. The next part is the demand section. Here we can enter the amount of fibers that are required for each type of customer. For instance, we can indicate the number of active fibers for both PON and point-to-point customers. And we can enter how many spare fibers should be foreseen. In case of a fiber to the building design, we can indicate the amount of fibers on a per building level as well. For the spare fibers, we can select up to which layer they should be foreseen. Again, there are some general equipment costs related to the in-building deployment. There's also an option to use adjusted costs for multi-dwelling units. This might be useful when you have to take additional in-building deployment costs into account. Next, we have the rules for the drop, distribution, and feeder layer. If we quickly go through the configuration sections for each of them, you'll notice that they are fairly similar. Let's go into the details of the drop layer. First of all, we can select the layer strategy. This strategy describes how the cables and ducts will be placed into that layer, and what the general design will look like. We will go into the details of these different strategies in the following design videos. Next, there is a section for describing the ducts that can be used in this layer. There's 3 types of duct deployment. We could select conventional ducts. In this case, all the cables will be placed in a single duct, for which you can enter the costs. Or we can choose for using direct buried cables, in which case no ducts will be used at all. The most commonly used option is microducts with air-blown cables. In this case, we can define multiple duct types. For each duct type, we can enter the total capacity of the duct. For instance, let's create a new duct with 4 microducts. We can enter the spare capacities if needed. In this case, the new duct will always have 1 spare duct which cannot be used in the design. Finally, we can enter a material cost, which is expressed per meter. And we can enter the labor cost, which is also expressed per meter. You can also delete entries by pressing the cross next to the row. Here, we can indicate if we want to use the aerial deployment or existing pipes when possible. The next section allows us to describe the cables of this specific layer. Again, we can add new cable types or delete existing ones. For each cable, we can define the fiber count, which is the amount of fibers in that cable. We can also reserve a couple of fibers. They will be considered as spare capacity. And we can enter a bundle size. The bundle size is important when using certain strategies, such as shared cable feeder strategy. Again, we can also enter the costs associated with material and deployment of this type of cable. For the cables, we can also make a distinction between underground and aerial cables. Typically, aerial cables are more expensive because they have to withstand larger tensile forces. Again, we have a section to enter those equipment costs that are specific for the drop layer. In this case, this includes the drop boxes and the aerial drop boxes. Note that for each of these sections, you can click the Help icon in the title bar. This takes you to our online user manual. Here you can find an in-depth discussion of the available parameters for this section. Now, as we said, the settings for the distribution layer and the feeder layer are very similar. Again, there's a strategy section that decides how the layer will be created topologically, and a section for describing the ducts, the cables, and the equipment costs. On top of that, you can indicate a maximum capacity for your distribution point. This capacity is expressed in fibers, ohms, or cables. In case of the feeder, there's an option to configure the central office parameters. We can also indicate the size of the central office in terms of fibers or ohms. Besides the capacity, we can enter some information related to the active equipment as well. This concludes our brief overview of the rules and material. For a more detailed explanation about the different configuration options, we refer to the in-depth sections of the online user manual. You can also contact the CommStaff team to arrange a consulting session, where one of our experts will help you to analyze and translate your design topology.